So this is a piece of cake so far. Then we hit the roadblock. Okay, how do I proceed next? So I know that something is happening at this X star location, so I'm going to draw a line there. At X star, what's going to happen? Yes, sir.
Flux is going to cross from positive to negative.
Flux is going to cross from positive to negative because it signifies that, okay, this surface is hotter than the fin, so there is the direction of heat transfer coming in this way. And so this is going to be negative flux. This flux, which is positive, is gradually going to become equal to 0 at the point where the slope is equal to 0 for the temperature profile. The bigger issue is how do we draw it? Okay, so look at this. dt by dx and x. Look at this portion here. For that particular portion, the slope of the temperature profile is negative and it is decreasing in magnitude. Which means that if I draw it out here, and it's decreasing in what way? It is decreasing exponentially. Because if the temperature profile is exponential, the slope is also obviously exponential. So it's decreasing, going to 0, which means that the heat flux is just going to be a scaled parameter, but the mirror image of this guy. Does this make sense to everybody? This is dt by dx. What's flux? Minus some constant times dt by dx. So I'm just going to take this guy, draw the mirror image right here. Then I look at the next portion of the temperature profile, which is after this X star location right here. Temperature profile is exponential. The slope is increasing in magnitude and positive. So if I draw dt by dx, it is going to be this way, which means that I have to reflect this as its mirror image, and if I draw it out, the flux is going to do the following. Does this make sense to everybody? This is before X star. This is after X star. The flux is nothing but the negative of this curve. So essentially I'm just taking this curve and mirroring it out. In the first case, my temperature profile is negative, the slope. So I'm drawing it in the fourth quadrant down there. And then it's increasing in magnitude. And so the flux is going to be doing the following, as I've drawn there. And in the second situation, my temperature profile is positive, and then its slope is increasing in magnitude exponentially, which means the flux has to be the opposite of that. So there is an inflection point as it crosses over. And the physicality of that inflection point is because of the temperature changing its nature, added to it the temperature being exponential distribution. Okay? So I hope this makes sense to everybody. This is within the fin portion. Typically we have not seen this kind of a profile before, because even though we have seen nonlinear temperature profiles, quadratic and so on, if I take a quadratic profile and if I look at the slope, its slope is linear. So which means that I'm not going to be seeing odd kinds of things like that happening for the flux. But in this situation, the temperature profile itself is exponential, and so its slope is going to be exponential, and that's going to behave in weird ways depending on what the temperature is doing. Okay?